Hello dear viewers, and welcome back to the second part of my video on the Hohner Rhythm 80. If you've missed the first part, you might want to check it out now in order to experience the unmodified sound of this wonderfully retro machine. This video, as I've already announced in the last video, is focused on a number of mods I've performed on my unit. There are three types of mods I will attempt to add to the Hohner 80. The first is adding a Midi import, next I will add direct access to the internal trim pods, and as a last step I will try to add even more sound controls to the individual drum sounds. In the end I hope I will have created a supercharged Rhythm 80 I've decided to call the Rhythm 80 RS. So let's start by adding Midi in functionality. As I've already mentioned in my first video, there's a Midi kit by Tabotech that you can buy, but I've decided to create my own Midi kit from an Arduino board. It will probably be more limited than the Tabotech solution, but it sure will be a lot cheaper too. Adding Midi to old school analog drum machines like the Rhythm 80 is surprisingly straightforward, because of the way these machines create sounds. Basically speaking, the Rhythm 80's internal sequencer sends short 5-volt pulses to the parts of the circuitry that create the individual drum sounds, just like you send voltage to an old-fashioned electric doorbell when you press the doorbell button. So by adding, let's say, a battery and a switch at the correct position inside the Rhythm 80, you can manually trigger the drum sounds. Or you can automate sending voltages by utilizing an Arduino board. In case you don't know, Arduino boards are programmable microcontrollers. As they are very reliable, offer a large number of interface pins, are easy to program and cheap to buy, they are perfect for this type of application. So, the way this works in the end is that the board receives a Midi node on command for, let's say, the node C1. If this command is received by the board, it will set a specific pin's voltage to 5 volts for a duration defined by the node's velocity. This effectively turns specific pins of the Arduino board into triggers for the individual drum sounds, and the node's velocity into the intensity, so to speak, of the trigger pulse. In order for all of this magic to work, we need an Arduino board as well as a Midi shield and a script that makes the Arduino translate Midi nodes into trigger pulses. As I've already tried my hand on Arduino in the past and to add a fancy LCD display to my home server, I knew it would be possible to get this type of functionality up and running. What really surprised me though is that ChatGPT just casually created a script for me that just perfectly did what I was trying to achieve. It's both amazing and scary how these hyper-specific tasks are really easy for AIs to do. You can find the final script as a download down below. The next step in the process is to at least add the right places in the circuitry. Of course, you should unplug the unit before working on it, and this is probably also the point in the video in which I should remind you that I can and won't take any responsibility for when you smoke your unit. All the mods I've performed work fine for me and should probably do so for you, but please solder responsibly. To locate the trigger points needed, the Tabotech installation instructions come in handy, as they give us all but one location to add some wires to the circuitry. All but one because the instructions get one trigger point wrong. The second trigger point for the cowbell isn't located here, but here, as someone on the Modwiggler forum has pointed out. You also still need to connect the Arduino board to ground, which can conveniently be done here. In order to power the Arduino board internally, you need to draw 5 volts from the power supply and connect it to the USB port of the Arduino. With everything connected and powered up, you should now be able to trigger the sounds by the Midi nodes defined in the Arduino script. In the script you can change the nodes that trigger the instruments, how node velocity affects the length of the trigger pulses, as well as the Midi channel nodes are received on. By default it's set to Omni. The way velocity is configured at the moment, high velocity creates multiple triggering of totonal sounds. I left this in because I think it leads to some very weird but also interesting results. So with the Midi modification done, the next mod is to replace the onboard trim pods with full-size replacements. Note that there are 3 different pot values needed here. 250 ohm for the decay pods, 100k pods for most of the volume pods, and 500k pods for the volume pods of most of the noise-based sounds. Originally I had also replaced the noise intensity trim pod, but either because my cheap eBay pods are too low in quality or because the extended wires, this led to all the noise-based sounds sounding absolute crap, so I put the trim pod back into place for the noise intensity. With all the trim pods replaced, one last idea was to add some more controls, so I looked into some of the resistors of the tonal sounds to see if I could replace one in order to achieve pitch control. This worked great with the bass drum, but not so much with the other drum sounds. The pitch range of the bass drum is greatly extended by bridging this resistor right here, but I could only achieve a very narrow effect on the other sounds. Also, as the individual circuitry is a very fragile balance of matched resistors and capacitor values, this would also affect the decay with some sounds, effectively rendering these mods pretty useless. The last and possibly biggest challenge was to squeeze all of these wires back into the case. I had already thought of designing and building some kind of cover panel to fit all the pods and the Arduino board as well as the Midi socket, but in the end getting it all squeezed in and the lid closed was quite a challenge, but I did end up managing to fit it all in. In order to showcase what it all sounds like, I created a little jam. So here we go. Okay, so much for the demo. I hope you liked the video. This mod has by far been the biggest project I've ever done on this channel. It took what feels forever to finish, especially as I did quite a few mistakes when designing and building, but in the end it was at least twice as fun as it was frustrating. So quite a good rate, I guess. So much for today's video. See you soon with another unmodified synth.